What is matter? Matter is anything that has mass and occupies a volume or takes up space. Matter is composed of atoms.
What are atoms made of?
Atoms are made of three basic subatomic particles: protons, neutrons, and electrons. The protons have a positive electrical charge, the electrons have a negative electric charge, and the neutrons have a neutral or no charge. The protons and neutrons are heavy and make up the nucleus, which is the dense core of an atom. The electrons are small particles that orbit the nucleus. The protons and electrons balance each other's charges. When the number of protons to electrons is equal, an atom's net electric charge is zero, or neutral.
What happens when an atom has more protons than electrons, or vice versa?
When protons and electrons are in unequal numbers in an atom, the atom becomes what is called an ion. An ion is a charged atom or group of atoms. When an ion is positively charged, it is called a cation, and when it is negatively charged, it is called an anion. Now, electrons in an atom like to occupy specific energy levels due to the electromagnetic force, which makes electrons like to space out from each other. Energy levels can be thought of as the layers of an onion. The electrons closer to the nucleus experience more attractive force due to the positive nucleus, and therefore have less energy, kind of like when two magnets spin near each other and spin slower the closer they get. Likewise, electrons in the outer shells have more freedom to move around.
How do we know what type of atom an atom is?
An atom is identified by the number of particles in it. Since protons and electrons are equal in a neutral atom, we just use a number for that, the atomic number. Atomic number tells us what chemical element an atom represents. A chemical element is a substance with only one type of atom. All of them are the same, at least proton-wise. An element can have varying numbers of neutrons. These are called isotopes. Since neutrons are neutral, they don't change the element when you add or subtract them. They do, however, change the mass and stability of that atom. Also, the other number we use to measure an atom is atomic mass, which is represented by the unit Dalton, also called atomic mass units. This is usually the summation of the protons and neutrons. The electrons aren't usually included because their mass is so small, about 2,000 times smaller than a proton, that we don't count it. It is the difference in size of protons and electrons why they don't annihilate each other, because particles of similar mass and opposite charge literally neutralize each other out of existence. But the mass doesn't disappear. Instead, it is converted into energy. This is an example of Albert Einstein's well-known equation of mass-energy equivalence. Basic physics out of the way, let's get to the whole reasoning behind chemistry. Only a certain number of electrons can fit inside each shell, and the last shell, the valence shell, is the shell that deals with chemical interactions. For example, the chemical element hydrogen is just one proton and one electron. It is the simplest atom and the most abundant in the universe. Hydrogen has only one shell. The lowest shell requires 2 electrons to be complete. Hydrogen by itself only has one. That is why, even in its elemental state, it has 2 hydrogen atoms sharing 2 electrons. This is called a covalent bond, and it is a form of chemical bonding. The other forms include ionic and metallic bonding. Higher shells usually like 8 valence electrons, and even higher shells 18. All in all, atoms like valence electron numbers in the multiples of 8.
In metallic elements, the metal atoms are actually metal cations, surrounded by loose electrons that aren't bonded to one particular atom. This configuration gives the atom an easy way to give up its extra electrons and become stable. These loose electrons are also the reason metals are shiny, because they reflect photons easily.
If you knew this, then why did you ask?
Just to confirm, an ionic bonding is when 2 atoms completely exchange electrons instead of sharing, forming 2 oppositely charged ions. These ions attract each other and form crystal structures. An example of this is the reaction of sodium and chlorine. Elemental sodium exists as sodium plus ions that have 10 electrons, 2 in one shell and 8 in the other, surrounded by one extra delocalized electron. This tells us that sodium has 11 protons, thus it is element number 11. Chlorine, on the other hand, is a diatomic nonmetal gas that has 17 electrons, with 7 on the outer shell. To form 8 electrons, the 2 chlorine atoms share each 1 electron. These elemental forms are not the most stable forms. This is the reason chemicals react.
Right. And in this case, when sodium and chlorine react, the chlorine pulls the extra electron from the sodium, forming a positive sodium ion and a negative chloride ion. The compound formed is sodium chloride, commonly known as table salt. Two very reactive elements create a totally innocuous compound. This is because they are now stable. Also, the reaction is exothermic, which means the atoms give off their extra energy in the form of electromagnetic radiation, typically as light and heat.